Alright, so now I'm gonna do this list here. I was trying to solve, I had a bunch of problems trying to do the git for this thing with the remote, but then eventually figured it out, so I have to do this list here now. I want to do this list. So let me put some music again. So first I'm gonna read this stuff here. Python has become an essential tool in virtually every scientific application around the world because of its power and versatility. It is a general-purpose programming language that supports different paradigms. It is widely used in scientific and specialized applications. JavaScript. Let's get to the differences. Now that you know what they are used for, let's see how they are written and the difference in their syntax. Oh, another thing that I thought about. So maybe I'll create a different folder here. Language differences hierarchy. So what I'm gonna do is I'm gonna get all the built-in methods for most of the languages. Then I'm gonna connect them into a network X graph. So I can see the visualization of the tree from C to C++ to everything else. So I think that's the first initial step. And see where they diverge. Yes, I think that's the first project that I'm gonna do. Oh, I think I opened the wrong one. Language hierarchy. So now is the problem is git init. Yeah, I think I will add show a remote repo after I have something. So the issue I was having is that I was trying to push changes to the remote repo. So when you create a remote repo in GitHub, you need to add the origin from the local to the remote. And you do git add remote origin and then the link to the remote repo. And then after that, GitHub tells you to push from this to the remote. But if you don't have any changes, it's gonna throw an error. And then I was having a lot of trouble with that because I did a bunch of different things. Got confused. So I figured out that first you need to create stuff here and then do a commit. And only then you can push. So I think I'm gonna do, oh, and this is the command to create a file here. Script.js. Echo is the command line command to write stuff. And this arrow here shifts the output to this file here. So if I do echo and I write some stuff, it's just gonna print that in the terminal. But if I use this, it's gonna create a file and then ask for the input that I wanna put in the file. I'm just gonna leave it empty, then it creates the file. And then I can see that I have this change. I can add here and make git commit JS file. Then git status. And I tried to change the name of this branch master here. That was a problem that I had. Because when you, I think I'm probably gonna have this problem again, maybe. But when I pushed, it created a different branch on the remote, because the remote branch is now main and not master. So when I get to that, I'll figure it out. But I think that's the first thing I'm gonna do. Let's create the network X with this relationship between languages and built-in methods from each language. Now that you know what they're used for, let's see how they are written and the differences in their syntax. Oh, I was researching this before. And this was for the Network X project with Python to navigate through the map. So I think I'm going to close this as well and look at it later. So programming languages. All programming languages and the language were built in. So hopefully I can find this. Might be somewhat difficult to find. I don't know. I don't know actually. I just want the most used. So maybe I should create a README as well. I think it's MD. And I'm gonna put the list here. So obviously C, C++, I don't know where C sharp comes from. Then maybe I should put here. Actually, I don't think I'm gonna put C sharp. Then Python, JavaScript, Java, SQL, maybe, JSON. Trying to think about the most useful ones. So C, C++, Python, JavaScript, JSON, Java. What else? Rust, maybe. This might be too much already. C Sharp is faster and more secure variant of C. It is fully integrated with Microsoft's .NET software framework. So this .NET I don't understand really well. And maybe I should put, but I don't know if it's a programming language or not. So I'm gonna leave it out. And I think I'm gonna remove Rust. It was developed by Google to be an efficient, readable, and secure language for system-level programming. Distributed systems in which systems are located. So I think I'm gonna put here the ones I'm not sure about, and the ones that I'm probably gonna do on top here. So there's Swift and Kotlin, I think, for Android development. iPhone. PHP as well. PHP comes here. Kotlin. Android. So Rust is here. So I think this is enough. So maybe I'll search one by one because it's probably gonna be easier to find the origin of all of them. It's probably all from C, but there might be differences. Code blocks in Python and JavaScript. Each programming language has its own style to define code blocks. Let's see their differences in Python and JavaScript. How Python defines code blocks. Python relies on indentation to define code blocks. When a series of continuous lines of code are indented at the same level, they're considered part of some code block. So JavaScript uses curly braces. Variable definitions in Python and JavaScript. The assignment statement, the most fundamental statements in any programming language. So you assign a variable like this in Python, and with this in JavaScript. Yeah, so I have to specify which type of variable. So that's another thing that I never thought about until now. That Python is probably, you can probably change all variables, I think. Then JavaScript, you can't change the constant, you can change the other ones. So, yeah. Variable naming conventions in Python and JavaScript. Python and JavaScript follow two different variable naming conventions. Yeah, but this is not from the language itself. So underscore in Python and lower camel case in JavaScript. How to define constants in Python? In Python, we rely on naming conventions to define constants because there are no strict rules in the language to prevent changes to their values. Yeah, so just like I thought. This serves as a red warning for ourselves and for other developers indicating that this value will modify the program. Const, okay, const name. JavaScript has only two numeric types, number and big int. Integers and floating points numbers are both considered to be type of number. There is a special value called none that we'll typically use to indicate that a variable doesn't have a value. Is no. Okay. The undefined value in JavaScript. Undefined, x undefined. Primitive data types in Python and JavaScript. Oh, another thing that I just thought about is that I forgot to do the .env there for the environment variables in the project. I don't remember really well which variables that I have to put there. And there was something about passport as well for authentication that I don't remember really well. But I guess I'll leave that to the part where I'm actually gonna use Mongo to do the free code camp challenges. Primitive data type in Python and JavaScript. Data types represent the most fundamental values that we can work with in a programming language. So Python has 4 primitive data types: integers, floats, booleans, and strings. It has 6 primitive data types: undefined, boolean, string, number, big int, and symbol. How to write commands in Python and JavaScript. Commands are very important to write clean code. Let's see how you can use them in Python and JavaScript. Single line comments, command, multi-line comments. So tuples in Python, we have a built-in data structure called tuple that is very similar to a list but immutable. There's built-in data structure with these characteristics. There isn't, okay. So no tuples. Python lists are used to store sequences of values in the same data structure. They can be modified, indexed, sliced in the program. In JavaScript, an equivalent version of this data structure is called array. That's pretty much the same thing. There's a built-in data structure called dictionary, and then JavaScript doesn't have dictionaries. Doesn't have this type of built-in data structure, but there are certain ways to reproduce this functionality with certain elements of the language. Oh, so I didn't know that. Operators in Python, you can have, I guess you can have variables that are equal to a dictionary there. Like on one of the difficult camp challenges. JavaScript does not have a particular floor division operator. Instead, we use this. So guys, I'm gonna search for this stuff. Because here I'm not gonna, yeah, so Python is init, JavaScript is constructor. It's pretty much the same thing. The thing that I don't understand is why not make everything the same name? Why change for each language? There's stuff that does the same thing. So let me think. Uh, so here it is. So how can I get this diagram here? So Fortran is probably the closest to machine language. Where's assembly? I think obviously I'm gonna ignore these ones, just the first ones. So I have C coming from here. The thing is, this is not really clear as well. Oh yeah, I have the list. I can just look one by one. like I said before. One of the most widely used programming languages of all times is a general purpose language designed for using the semicolon. I think I'm gonna look one by one. It's easier. Start with C. Uh, just having a look at the family tree of computer languages should clarify the position of C. So let me see. Where is it? Here. Yeah, but this is too complicated. I can see here C++, C of classes, concurrent C, Objective C, Python here. Oberon? So I'm not sure what this is. I've seen this ABC a lot in Python and researching the libraries. So Python and JavaScript come from C++. Which means that the only difference between them is the methods and how they are built. So, an SQL should be here somewhere. So I'm just gonna put here C++, C++. I think C++ comes from C, but I'm not sure. Yeah, yeah, obviously it comes from C actually. Because it's C++ and C Sharp, same thing. JSON probably comes from C++ as well. Descendants, C++, Java, Objective-C, but also many dynamic languages such as Perl, Python, or JavaScript were all alive. So Java comes from C++ as well. So everything comes from C++, apparently. We're the first programming language. I'm not compiling. Fortran, Pascal, Lisp or Basic are also compiled. C holds an interesting ecological niche as it has been considered from the beginning as a kind of portable assembly language, which means that conversion from a C program to any assembly language of the instruction set of processors is intended to be straightforward. It is still mostly true after 40 years. Damn, my throat is annoying me. Still, C is far from perfect or even fundamental. Its underlying model is instruction based. So I'm gonna search one by one now. I think it's better. These are things from the project page. So C++, a little bit of C++, Python, and C. And this library is written in a mixture of C and Python. So there's 3 different ones. Python interpreter pre-installed on Mac OS and most Linux distros. This is what runs when you root type Python and the command shell prompt is written in C. That just a Python interpreter by itself is almost useless without also the standard library. Only used install libraries. Those libraries are written mostly in Python itself and performance critical sections written in C. More complicated is that in addition to CPython, there are at least 4 other implementations of the Python language. JPython, which is written in Java to run on the JVM. IronPython, which is written in C# to run on the net. So, and this is more complicated. Stackless Python, which is written in C and architected to use thread-based parallelism. And PyPy, which is itself recursively written in Python and is a JIT-style native compiler. It is actually faster at executing a given Python program than the CPython interpreter. So I'm gonna leave C just for simplicity's sake. So now JSON is probably gonna be the same. It's Python. Because yeah, just JavaScript object notation. Text format that is completely language independent but uses conventions that are familiar to programmers of the C family of languages. These properties make JSON an ideal data interchange language. A collection of name-value pairs in various languages. This is realized as an object record, struct dictionary, hash table, keyed list, or associative array. Another list of values in most languages. This is realized as an array, vector, list, or sequence. These are universal data structures. Virtually all modern programming languages support them in one form or another. It makes sense that the data format that is interchangeable if programming languages also be based on these structures. JSON will take these forms. There's another set of value pairs. An object begins with left brace. So I think I'm gonna remove from here. Doesn't make much sense. Leave it there. Java is probably C++ as well. Split is written largely in C++ because hotspots are heavily based Yeah, so C++, SQL. So now I'm thinking about the next part. I'm gonna get a list of all the built-in methods without having to copy manually in the documentation for all the languages. I don't think the list should be too large because I don't want, obviously, I don't want the code, I just want the instructions, like the things you can do, and just the built-in modules, not the ones that the library, assembly or C. 70s around the time Ingress was getting started at UC Berkeley. You guys are working on a contract for the CIA? CIA? Yeah, CIA. Got together and started a company called Relational Software. Their first product was a relational database called Oracle that used the C language for development. This would later become important. They decided to start porting to different platforms. Support SQL as the internal data access language. So I'm gonna put C here. So everything comes from C++ and C, apparently. The data definition language groups the commands used to define the data structures. Modification, alter, and destruction drop for database users. Data manipulation language, create, update, and delete data, adding, removing, or altering data. DKL, data query language, command to extract data from the database structure data. While the SQL means structured, doesn't really refer to the language type. It is more because you deal with structured data and the data models brings up a very synthetically structured language. Pure SQL is just a sequence of commands submitted to a server. There are no loops, no conditionals to decide if a command will be executed or dismissed. They are always executed if they are correct and if got the right to do so. It's not in the commands, so SML and DKLO are highly imperative in the declarative language. It's imperative, not in the CS sense, because your issue orders in sequence. So this answer contradicts the other one. You won't tell the computer where to create the files, structures, and settings up to the server, the database engine to follow its configuration parameters, and even decide the best execution plan. Of course, you can specify choose memory for temporary tables or choose an SSD. Not no, she doesn't need the table. It's very abstract language in that regard. So it might be better to search for videos in this one. So maybe I'll actually take this off here because it's not that important. So it's gonna save me time. Because it's very simple language. Naturally, a question may come from curiosity. Began in 94 as a set of common gateway interface binaries within the C programming language. And what a surprise. So let's see the Stack Overflow answer. PHP, what I call the mother thing, C. Yeah. She was originally based on Perl programming language scripts rewritten in C for performance by user. Okay. It's server-side scripting language, which is widely used open source general-purpose scripting language. So now I have all of them. So, oh, except from C. I guess I'm gonna put it there, but not really gonna use it. First step, in writing a program is to realize that you want to make the computer something. So that all C compilers are implemented in common language. Just gonna put assembly and not find anything. Ah, just to save time. So this answer is slightly confusing, but I guess it's saying that the compiler is what matters. Differences in compilers for programming languages are programs some is written in some kind of programming language. It's not written in Go itself. GC frontend is written mainly C++. Just gonna leave it this, whatever. Already written in C++. C++. So everything comes from C++ and C. So what I'm gonna do after build this, search for differences. Yeah, I wanna make something that I can change the color of the nodes depending on which language it is. And when they have something in common, I can make the same color. And when they have something different, then it stays the normal color of the language. So the way that I'm imagining is like a tree. It's probably going like all comes from C, then C++. The C, then the built-in methods, then C, C++, then the versions of all the language from C++. I think that's enough. And Kotlin. Enough. Its files are published in GitHub here. It should be 50-50 split between Kotlin and Java. Kotlin, Java, C++ with Objective-C. Yeah, but Java is written in C++. I'm gonna say Java then. The question is how I'm gonna put all the built-in methods in a list. Maybe I can do this in Python instead of doing in JavaScript as well. It's gonna be easier because I already know the library in Python. The PyVis library. So I think I'm gonna delete this file. Maybe I'll leave it there. Echo hierarchy. I'm not sure if I'm writing this the right way. I was looking at the Kotlin. Modern compiler in its source language is called bootstrapping. Process of writing a compiler in its own source language is called bootstrap. In fact, at its earliest stage, it involves in writing the compiler in another, often lower level programming language, supporting a reasonable subset of the features designed for the compiler's source language. Then, using the subset of the features that were implemented in the first step, one can rewrite the compiler's code in the language it compiles. It gives you a compiler of a subset of the language that is written in the same language. Afterwards, one can add new features, not using them in the code at first, and build a more powerful compiler at each time, so on iteratively. Kotlin used the Java programming language for its initial implementation, and most of the Kotlin compiler's source code got rewritten to Kotlin. Now most of the new code that is added to the Kotlin compiler codebase is written in Kotlin. Yeah, but I think for me what matters is the initial compiler to figure out where the common built-in stuff. So hierarchy. Yeah, I think this is the right way. Just That's it. That's why. Okay. So now, yeah, the issue is now I have to initialize this as a Python environment. I need to set up the interpreter. It's just easier to open PyCharm so I can skip this stuff. So I'm gonna use Conda because I have to use CUDA for the network access stuff. So I think import. I think network.pyvis. Pyvis.network. Stop this. No. Conda install. Don't remember if this is the correct. What is this mistake here? No, I think it was import. I don't remember. I have to check. Did I click here? So while I'll wait for that to open, or PyCharm to open. Oh, so that's weird. I don't know why it opened from, it didn't open the project that I was working on before. Oh, and it wasn't this project that I wanted to open. Yeah, but whatever, I just opened the other one. Obviously, I can look it up, but I think it's gonna take more time, so. So, list of all building methods and data structures, C++. computer science, bootstrapping is the technique for producing a self-compiling compiler. It is a compiler or assembler written in the source programming language that it intends to compile. An initial core version of the compiler, the bootstrap compiler, is generated in a different language, which could be assembly language. Successive expanded versions of the compiler are developed using the minimal subset of the language. The problem of compiling a compiling compiler has been called the chicken or egg problem in computer design, and bootstrapping is a solution to this problem. So these are the tips. Did it change everything? So I think it was, oh, maybe it's because I changed the file. Yeah, changed the folder to this one. So I'm gonna just copy from here to here. Yeah, import pyviz not from pyviz.network. Import network. Okay, so now it works. No, it's weird that's like this. And now it works. So I think I'm just gonna use PyCharm. It's better for Python. And I don't understand why the formatting is like this. Oh, maybe I can't change this steps of file in Python. So yeah, that's easier. Typical bootstrap process works in 3 or 4 stages. I think I'm gonna search that for to watch later. Bootstrapping compilers. I wanna close this stuff. I'm gonna put in a comment here this stuff that I wanna do. So 4 hours here. Just unused imports. The problem is how I can get all of them in a list. I remember I have it on the folder because I took from the book there that I was reading. Oh, the issue is that it's not only just the types. Now I remember. You have difference in namespaces as well. In execution context. Which might be another difference. So it might be another a lot more harder than I'm thinking it is. And here there's a lot of them. And so it's probably gonna be hard to find this. I don't know if anyone has done this before as well. Maybe for Python JavaScript might be easier. I'm searching online to see if C has any built-in data structures. Like C++ or Java though. Static arrays, dynamic arrays, linked lists, stack skills. Maybe if I could create a web scraper, just scrape the documentation. But that sounds very complicated. Hey, Edison, what's going on? I'm starting to think that it might be too hard of a project to do it as the first project that I do. Because it might take me too much time. It might be better to do the JavaScript stuff first. Because it seems a lot easier. Maybe maybe I do just with the simple ones. Oh, I have it here. For Python, JavaScript, Java, PHP. Oh, I remember there was something that I could do now. Just see this. But it was just for libraries, not for the functions itself, the structure. It's so weird to me that this doesn't exist because it's something that is used so much by so many people that it makes sense that to build a list with all the methods and all the stuff. I guess the documentation is that, but maybe I should search for C++ official documentation. And then I can create a web scraper and scrape the documentation. I think that might be good. Because then I'll have to learn how to build it. To build a web scraper. It's gonna be useful. So I know at least Python has it. Not sure about JavaScript. C++, I guess the reference thing works. this website here. Yeah, so maybe C++ is gonna be too hard. It's better to just do it for the other languages. And then once I learned all the other languages really well and how they connect with C++, then I can think about C++. Headphones online. Yeah, so I'm gonna scratch C, C++ and C sharp, and then just do. I'm gonna see if JavaScript has official documentation. I think I'm gonna start with JavaScript and Python, and forget about the rest until I have something. So this is documentation, guide, intermediate events. Yeah, so now I think my goal is to create a web scraper that is gonna scrape this. And it has to get this and put it on a list. But then it has to get all of this as well. So let me see if there are the data structures here as well. So big int array. So what I want to get is this thing and the name and put it on the dictionary, I think. So it's the name of the thing and then how to initiate it. Primitive wrapper objects used to represent and manipulate numbers. Yeah, so here are all the data types, I guess. Built-in objects. Then the expressions. State statement declarations. Yeah, this might be, so I might have to go for this syntax instead of this. Yeah. Oh, so there is static JavaScript as well. So maybe I should inspect, should, now I'm not sure if I create the, try to create the web scraper for this site or the other one. This one seems more complete and organized. Yeah, but here I might miss this stuff here. Let's see if here it talks about, here. Yeah, the biggest challenge is how that I'm gonna create a web scraper to get exactly what I want out of this. So I think I'm gonna organize it the same way that it's organized here. Built-in objects, expressions, and operators, statements and declarations. But just the name, I'm not sure if it's gonna be enough. And then if I want to be even more ambitious, we can probably try to figure out a way to put the link as well to the page. So I can click on the graph and go to the link, but that's gonna be extremely hard. So I think I'm gonna start searching for how to do this. And forget about C++ and the other languages. And this one I can do it like this. And it describes the standard library that is distributed with Python. It also describes some of the optional components that are commonly included in Python distributions. No, so here's the same thing, I guess. So I guess I'm gonna use this one because the same thing from uh, JavaScript. But here is also useful. Yeah, but I'll start with the other one. Yes, get out of here. Yeah. Yeah, so this one seems to be more organized, but also has a lot of information that's gonna make it difficult to visualize the data. So it just contains everything the same. Yeah. Mm. So probably these are all the built-in functions. No, I'm not sure which one should do. It's gonna say BeautifulSoup. But the issue, these are all on the same page. No, so it just changes here. Let me see here. This one changes at the end there. So I think this one is gonna be easier. I think what I'm gonna do is just get the names here. It's probably gonna be a lot easier. And just get all these names. I can do both, so I'm gonna start with this one. I'll do JavaScript first. So this one, yeah, dev docs. So what I'm gonna do is scrape that, get all the information, and create the graph to represent. Then I'm gonna play around with the graph to see if I can find common traits and differences between the languages, the two languages. And then maybe I can create subsections as well to see the types of the language that I want to understand. Oh, I forgot about Node.js and React. I forgot to type it here. But I know they come from JavaScript. Let's see if there exists here. So here, there's also React, Redux, React and Redux. So this one might be better. overall. Nodes obviously gonna have here. Yeah. Node.js. So, okay, so I'm gonna forget about the rest, otherwise I'm gonna lose focus. I'm just gonna do the simplest thing I can do. Do I have something? Okay, we notice a few things about the URL. Acts as a separator, it indicates the end of the URL resource. The reference is the page we're currently on. When you navigate back and forth through the pages, you'll notice when the parameters change. HTML stands for hypertext. Okay. When you access an URL, your computer sends a request to the server that hosts the site. Any technology can be running on the server. JavaScript, Ruby, etc. Process your request. Eventually, the server returns a response to your browser. Oftentimes, the response will be in the form of an HTML page for your browser to display. HTML describes the structure of a web page semantically and originally included cues for the appearance of the document. Inspect HTML. Chrome, Firefox, and Safari users can examine the HTML structure of any page by right-clicking. Okay. So basically, use the developer tools. Optional is a simple interactive computer programming environment used via your browser. This is just for code alone purposes if you don't already have an IDE. So I think I'm gonna do this. This one to the left and this one to the right. You just press window and left key, window right key to do this. Request BeautifulSoup. So yeah, imagine I'm gonna need BeautifulSoup. Uh, import request. Import request maybe. I thought I have this library. Maybe I have to do this on the Conda terminal, not here. But we'll see. Help us assemble the information NumPy. You can follow along part 2s. So, oh yeah, requests. From import, from requests, import, yeah. Then from PS4, for beautiful. So I think it worked here. So it didn't work. You can press Alt here. It's not showing up. Maybe I wrote it the wrong way. Beautiful. So let's try that. It's very likely when we run our code to scrape some of these movies, we'll get the movies name translated. Request contents of the URL. Get the contents of the page you're looking at by requesting the URL. The following packages are not available from current channel. There's always these packages, always something going on that makes it hard to install. Maybe it's the version that I'm using. Let me see if I can do this on the command prompt. Oh, so already installed? That's weird. So I don't know what's going on here. Yeah, I remember sometime I used this. Maybe I'm importing correctly. I hope that's the case because otherwise I'm probably gonna spend a lot of time trying to figure this out. Because then I'm gonna have to see what this channel thing is about. Oh, maybe I'm installing the wrong one. That's why it's not recognizing. But it doesn't recognize beautiful soup. Why it doesn't work here? Okay, so apparently, hopefully this works. So it should be installed. Let me see. I'm gonna check the library, I think. It's probably easier. BS4. So there's no beautiful soup here. Beautiful soup. So why is not recognizing? But it's still maybe just the way that I'm writing there, but I think it's unlikely it should be that. Oh, that's there we go. So it's caps lock and not. So the tutorial there is probably off, or did I see it wrong? Oh no, yeah, I didn't see that. Okay, yeah. So here it is, class beautiful soup. Nice, thank God. Otherwise, I would probably spend a lot of time trying to figure out how to install this properly. So I need to get a URL, and it's gonna be devdocs.io, I think. So yeah, and whenever there's a version, it's gonna be this tilde thing here. So I'm gonna get this URL JS equals this. Close this for now. I'm gonna make URL equals to this about the JavaScript. And maybe I should put module there. Let's see what this does. Yeah, so I'm gonna make it JS equals JavaScript. I could make a list as well called languages. I'll think about that later after I figure out how to scrape this stuff. But I'm thinking about formatting this so I can loop through a list and then make the name each time so it filters, but I don't know. Results request.get URL headers equals headers. So I'm gonna use JavaScript first. Request.get URL.js. What is the headers here? Accept language. It's very likely when we run our code to scrape some of these movies, we'll get the movie names translated into the main language of the country the movie originated in. Use this code to make sure we get English translated titles from all the movies we scrape. So I'm not sure. I don't think I'm gonna put this stuff here. And now why I'm getting this. It's no typos. So maybe I have to use the header there. Request is the variable we create to start our request.get. So maybe it's just request. Yeah, go. And only get doesn't make sense. Oh, maybe it does. Yeah, maybe it's the other way when I'm using import requests. directly. Make the content we grabbed easy to read by using BeautifulSoup. And so this is gonna get the entire web page. Soup is the variable we create to assign the method BeautifulSoup to, which specifies a desired format of results using the HTML parser. This allows Python to read the components of the page rather than treating it as one long string. Initialize your storage. Your code should now look something like this. Find the right div container. So I think I'm gonna change the title here. Title. Final method extracts all the div containers that have a class. So let me inspect this stuff. So I have the head here, the div, header. So this is inside of a section. See. So this section and the div here. Div container, section, class, sidebar. Your row navigation. And then here there is the name. Inside the class name of the language. Yeah, this is gonna take me some time to do. But I think it's good to learn. So what I wanna do, let's go here, here. Oh, I can't scroll this, but I can scroll here. And it doesn't show anything here. So it doesn't update. Yeah, sure. Yeah, I think I'm gonna watch a video about this. It's probably more efficient. Then I'm gonna create this soup equals beautiful soup object results.text HTML parser. So here is results dot text. Print. I want to see what happens when I do this. Let's run. So it's giving me the page there, the HTML of the page. This is cool. Huh. But I wonder if it gives me all the lists or. So I think I get now what I'm supposed to do. So I probably should use this, then find a way to get the keyword that I want specifically. But what if there are more than one instance? Which is probably very common. There's probably a way to handle that. Yeah, I want to get the class actually of the element and get that element. Maybe there's a way to get links as well. So I'm probably gonna have to use Selenium. I think Selenium is a Python library that allows you to move between things. Move between pages. Because I want to extract. What's going on? Is it loading now? Oh, closed this. Oh, that sucks. What happens there? Maybe if I open again. What happened? And this might be a problem as well. I think I clicked here. Yeah, I don't know what I did here. I prefer this format, not the other one. Yeah, but what I want to do is create something that access this page, then gets the thing that I want. Yeah, maybe this page is gonna be hard to get, so maybe I should focus on getting these names first. On the left here. So it opens this, then it opens this, then it loops through this and gets all these names here. And then same for here. Same for here and so on until it reaches that. And I want to put all these names into a list. Then I want to create a graph. So I also have to think about it. It's better to make a dictionary, not a list, because each of these is gonna contain a list. So dictionary, the key as the value here, and the list as the values that it contains. Then once I have that, then I can figure out how to create the graph from that and do the same thing for the Python stuff there. So I think I'm gonna need Selenium and BeautifulSoup. So here is showing me menu. Trying to see if I can find the classes there with CSS, JavaScript, Python, the name of this stuff. Yeah. So class search tag should be inside of this, I guess. So I'm gonna watch videos about Selenium and BeautifulSoup. And this I can close for now, I guess. I'll focus on this stuff because it seems easier. Then once I have this, I can make a website out of it, I think. Very simple website. Or I can create a page that has a button that clicks on the languages. Yeah, but then it's gonna be a lot harder because I was trying to do that before, and it's a lot harder to do. This stuff that I was looking at before. Oh, I can close this one and close this one. Trying to free up space here at the top. I'm gonna close this one for now. I think I'm gonna close this tutorial. Which is BeautifulSoup. Right? Wow. So this guy is good. I'm gonna watch this video. I think I'll open this one here. Then here. Yeah, this is what I'm gonna do. Then I'm gonna learn this stuff that I was intending to use already for another website that I want to build. Hopefully it's not a waste of time. Then once I finish with that, I can start on the JavaScript trace thing. And then I can go to the free codecamp projects. So I'm not sure.
So what this allows you to do is actually extract information from HTML documents and then modify HTML documents as well. So you could use this for web scraping. You could also use this to read in, say, an HTML file, modify it programmatically using Python code, and then recreate like a new HTML file that has those modifications to it. It's very versatile. There's a ton of stuff to show you, but in this first video here, what I will be doing is just giving you an introduction to how it works, showing you how to read in a local file, showing you how to read in HTML from the web, and then
I think the upside of this is even if it takes me more time, I can use it to study this stuff. Even on React and Node.js, because I can do the same process for those languages. And it's gonna be a lot easier to find whatever stuff I'm lacking on. And then I can use that to build the websites that show that. So it's kind of like a bug tracker, but in a different way, I guess.
Kind of just give you, like a brief walkthrough of how BeautifulSoup works and some of the main, most common functionality that you're going to want to know. In the very last video of the series, I will show you how to write a relatively automated web scraping program that goes and looks for prices of graphics cards. I know a lot of people are looking for graphics cards right now, so I thought that would be an interesting application that we could kind of conclude everything with is writing that code. Anyways, I hope you guys are excited. If you are, make sure you leave a like, subscribe to the channel, let me know in the comments anything you want to see in the series. Let's go ahead and get started. You here is coming directly from this documentation page. I've just kind of summarized it and grabbed what I figured was the most important stuff from here. Anyways, if you want to see all of the functionality, you can see there's quite a bit of it. This is quite a long document, then you can click the link in the description. All right, so the first thing we need to do when we're going to start working with BeautifulSoup is we need to install it. Now what we need to do is install the Python package, which comes from pip. So if you're on Windows, open up command prompt. If you're on Mac or Linux, open up your terminal, and then type the following, pip install, and then this is BeautifulSoup 4 like that. I think I spelled that correctly. So you're going to pip install BeautifulSoup 4, and then that should install the package for you. Now, for some reason, this command does not work for you. Try pip 3 install BeautifulSoup 4. If that doesn't work for you, try Python -m pip install BeautifulSoup 4. And if that doesn't work, try Python 3 -m pip install BeautifulSoup 4. Lastly, add a 3 here. Those are the kind of different combinations you can try. If none of those work, I do have some videos I'll leave in the description that show you how to fix your pip. Anyways, at this point, I'm going to assume that you've installed that Python package. I'm using Python version 3.8, I believe, right now, but you can do this in pretty much any version. It should work the same. All right, so now that we've got that installed, we can start writing our Python code. I'm currently in Sublime Text. You can use any editor that you like. It's just the one that I prefer for these types of videos. And what I'm going to do is start by importing from BS4, import BeautifulSoup like that. So this is what you need to do to get started. And then what we're going to do after this is I'm going to show you how to read in an HTML file and then to modify that file. Then later in the video, I will show you how to read in kind of a web page. So if you want to read an HTML file, first of all, you need an HTML file. So I have this kind of dummy HTML file here. I'll leave a link in the description. It's a GitHub repository that has all the code that I write here, including this document.
Oh, I had an idea now. I think I know what I'm gonna do. So let me open the other project here. I'm gonna open this one, and then I'm gonna use it to create a graph of BeautifulSoup. So now I have to think about so here I'm gonna import BS4. And this is gonna show the import of the thing. Let's run this. So I should create BS4 here, .csv. Oh, it's maybe because I changed the name. Yeah, I should get the habit of putting paths in a different way. The thing is, I always postpone this stuff. So where is this? This is in Python. No, but it shouldn't matter because it's in the same file. What's going on here? Oh, I overwritten this. God damn it. I need to put BS4 here instead. Oh, so now let me undo this and run again. Just so I don't have that file over there. The data frame changed and I forget about it, then might be a problem in the future. So. Oh, and this calls the graph, so that's why it opened that. So BS4. Now it should work. You can also do this. Okay. So now let's run. It should create a BS4 here. Yes, it does. So now, what do I want to do? So I'm gonna create both graphs of the dependencies of the color and the color file name and function file name, but I also want to put this script here to see what's going on. But this is in a different folder, so trying to think about what I can do. Can get a path here. So let me see if you got it. Absolute path. Okay. So now I can I think these are the same. And then I can do from job projects dot language. That's what I'm not sure about. So I'm probably gonna have to research that as well. What I want to do is import this file in this one and then run this. I should probably. So I have to think if this is meant to be a function or not. Find a file name here. Main. Find. And then here. Yeah, I'm not gonna change anything for now, but I would obviously put file name here. So now I'm gonna search for how to import a file from different folder. Python script. I know it's gonna tell me to do the doc notation, but search engine, this is not an answer you're looking for. Typically, you would structure your files into packages instead of modifying the search path. So if I use an init here, so I guess I can make new Python init and just leave it blank. I'm not sure if I can leave it blank or if I have to import this file somehow. I don't know. Python only searches the directory that the entry point script is running from and sees path, which includes locations such as the package installation directory. It's actually a little more complex than this, but it discovers most cases. Can add to the Python path at runtime. Sys.path insert one. So it's using the sys to do it. But why am I getting this mistake here? So let me see the folders. So this project in this on this folder here. And this one is on code. So maybe I should put code here. .shop. Yeah, but doesn't work. I don't like the solution using syspath there, because then my concern is that I might change the visualization script. Maybe what's easier to do instead of having to do this every time is just create a folder. Because I'm probably gonna have to do this every time I wanna run a script here. I can just create a folder. I'm pretty sure I could figure out with enough time. Scripts. Hopefully there's nothing wrong with this name. And then here I can put the scripts that I'm testing. Which I believe it was only that. No, the simple as well. Yeah, and now I can copy this and paste it here. Which is much easier. Oh, maybe it was the .py there. That was a problem. It could be that. So let me check. If I do like this, yeah, it doesn't work. So, oh, now I'm going back. And now I want to run this here. Maybe I should also turn this one into a script and then change it to run the whatever file is there. Yeah, I remember the issue I had with this was making this variable dependent. Oh, I can make the import inside this stuff. So I'm gonna do that. I'm gonna transform this into a function so it's better. I'm gonna make it main. Oh, that was confusing. Hopefully I can declare a function inside of the function here. Yeah, looks like I can. So here I'm gonna pass file name, then imports, then script. This is gonna be the script that I'm trying to script. Yeah, but then also I need to initialize it to none, and then it works. It's still giving me a mistake. I don't understand why. Yeah, so maybe I can't do this. Which is a shame. Here, obviously, I would erase this. Yeah, file name. And then here I would put script. Yeah, but this might be worse because then I'm gonna have to pass it as a string. So I'll think about that later, actually. So don't spend too much time on this and deviate the focus from the previous one. Just want to get this done and see what happens. Okay, so now I think I got here BS4. I need to change this name. BS4 script. So I'm importing this and I want to run find. And I want to pass nothing. I'm gonna have to pass. If I don't have to pass anything because I'm already declaring here it is default. Here I'm gonna initialize it to none in the beginning. So let's see if this works. 949. Find missing one argument. So yeah. I think I'm gonna pass an empty string. There we go. Yeah, so it ran that and they create this stuff. This fire script. Okay. So now what I wanna do is this graphs here. So I want the color graph and the execution graph. I think I modified some of them. Oh yeah, but I created new scripts with the modification. Because I wanted to filter out some libraries because it was looking too complicated. So this I'm gonna put BS4. So the app draw. Yeah, the app is here, BS4. This should be good. So run. Now I should get a file there. BS4 here. I'm gonna open this on Chrome. It went pretty fast. Nice. So this is the first one. Then I use this one. BS4. Run. This one might take longer, but it's pretty fast as well. because it's a small library, I guess. Or maybe there's something wrong with the code that I did, but I think it's correct and just the library is small. That's a bit. This one looks weird. Okay, so now it's normal. But why there is no text here? So there's something strange going on. Let me see the CSV. Yeah, so it should be a lot bigger than that. 80,000 files, 80,000 lines. So what's up with this? Oh, maybe because I changed the library. Let me see. I was trying to figure out where some functions come from and what they do before. So I changed some stuff on the library to see if it would work. I think it was on the pages. So there are options or configurations. And I learned that I can use Ctrl B to find. Just remember this now. Find where the functions come from. So I think I was on set options or options. This one should be good. Maybe it was on this file. Yeah, I created this function here. Just a copy of the interaction one. But it shouldn't change anything because it was working there before. So I'm not sure what's going on with this. So data frames here is probably correct. Font color white. Oh, I changed this stuff. Huh. Because it was this plus this before. So maybe I should print here. V. And print key as well. I also changed this file, I guess. Where is it? Hmm. Oh yeah, I changed here as well. I forgot to initialize the options with the function that I added there. Okay, so now it should work. Yeah, so it's just giving me yeah, that's the problem. Oh yeah, that's why I wasn't doing like this. Oh, I shouldn't have changed that. Because this gives me a list. But it's amazing that this one works. Yeah, and I remember verifying that. So maybe I should print now, just to see. Now it should take a lot more time. Yeah, now it's working. So I'm gonna change this again here. Because I changed it in the other. Oh, so this one doesn't have color file name. So I guess this one is just fast. Yeah, this one is working. And then funky graph. It's also zip, so we didn't change. Then execution investigation. Yeah, this one I changed as well. Because I saw a video that the guy said that beginners do this stuff of summing to get the string, so I thought it would be better to change. But now I realize that I'm actually summing the lists. That's why I did this way. And I think that's it. So now it should have worked. So this is gonna be for the beautiful soup, and now the script. And I think these are the only graphs that I need. The execution and the colors, the tree, it's not necessary. But I might have to filter out as well some libraries because usually there's a bunch of them, so it's kind of hard to see. So this one is normal. But this one seems to be smaller library, so might be possible to see. So this comes from Frozen, Bootstrap, Libre, Neat logging, parse. I think what I'm gonna do is call the one that I removed here. Here. Yeah, I'm gonna copy this file. I'm gonna create a new file here. So basically what I did on this one was filter out some libraries. So let me put yes for no, I'm on the same one here. Yeah, I'm gonna do this only for the execution one actually, because this one's a lot harder to visualize usually. And I'm just trying to see what are the main modules, what are the main files that get activated. So if I can filter out frozen, which is the import stuff. Oh, this is not so bad actually. You just need to find the first file. I made it so that the first file is a different color. It's green, but I'm not seeing it here. Where is the green file? Blue, blue. So it might be because it got overwritten all the other colors. The reds are the ones that have more than 10 connections, I think. The blues have 5 or less. No, 5 or between 5 and 10, and the orange has between 10 and 20, I think. So soup, CSC type. So beautiful soup stuff is here. So here is the part of the soup library. And importing stuff. So I think I'm not gonna use the. Yeah, I'm just gonna do this script here. Here I'm gonna do the script as well. I forgot to raise the print state. Oh no, that comes from here. It's here. Now I can close this file and I run this one. Here, here, and I can close that one as well. And then here I can filter out which ones that I want. Yeah, the names that I want here. Yeah, so this is just importing the library. So obviously there's a lot of connections here. Encodings, string, re-enumerate, soup, cv, css, parser.py. It's an important file. Apparently, Let me see the connections on this one. Copyright. Yeah, so there isn't much stuff here. Problem is that the ones in white are usually hard to figure out because there's so many of them. This is in socket as well. Makes sense because of the request. This is HTML init. Apparently is another package from Python. Might be interesting to check it out. And this comes from the lib.re. lib/re.py. So HTML init.py. Anaconda, the Anaconda. Oh, so this is not side packages. It doesn't come from the side packages. So it comes from here. Yeah, there's no HTML here. HTML. So I guess these are memory addresses. Yeah, interesting. I'm gonna close. I think I got the files that I wanted from this. Oh yeah, let me check the. I'm gonna close this one. It's not very useful. This is the execution of the import one. So now let's see this one. Yeah, this one is clear. You can see the start here. Yeah, this is gonna be the best one. I think I'm gonna close the other ones and just use this to study the library. And this is the execution of the script as well. Let me see. Yeah, but this only contains the color. So this is the first file. Oh, here it is. So this activates request API, which activates this here. BSFAR element. BSFAR formatter. Damn it. BSFAR dammit.py. Init. Collections init. It's pretty much activating all the files. Just wanna get a sense of how everything is connected here. And then I think I'm gonna follow I'm gonna close this one. This is the execution of the import one. Want to look better, I would have to filter this so these imports don't show up and this bootstrap stuff. I think I want to close this one. And I'm probably gonna close this one as well. Maybe I can make a directed graph here from this. I was having problem. I wasn't being able to make the directed for some reason. Maybe since this one is so small, it works. I guess it's just takes more CPU or GPU, and then it should update here. Oh, this is the BS4 script, so I should do script here. Yeah, now it's a lot more laggy, but has our arrows at least, so I can see what's going on. It's still very bad to see. There we go. That's what I want to change. So I want to catch them on a good state so I can pause this and rearrange manually. So now let me see. So this is pointing both there and there. Get this off here. So this module seems to be called everywhere. Let's see what this is. Collections ABC. It's probably built in from Python. And request adapters, models. Yes. Here's the BS4 stuff. So libabc. It calls directly from this one. BS4 element. Yeah, so I think this might be useful as well. So I'm gonna keep this one open and then I'm gonna use this one. to study the flow of this thing. Wish there was a way to untangle this though. And to align. Oh man. If I do this. I think I'm gonna do the same thing that I did on the other one and separate by these blue ones here. So I'm gonna stop here. So first I'm gonna watch the videos to get an overview. Then I'm gonna study this library. Just see if I can understand better what it does and how it's doing. And I don't think I'm gonna need to filter that because at least it doesn't look that complicated. Maybe I can filter. So let me see which models I have here. Maybe I can do like this. I opened VS Code by mistake. So here I can type. I'm gonna filter by the modules I have here, which is requests. And but then I'm not sure. Yeah, because so requests and BS4 should be enough. Because if I do that, it's gonna be a lot easier to. Okay, so here there's BS4. See if there's anything else. Uh, there's a lot of stuff here. So this is all in parts Bootstrap stuff. Then Python. I assume that it's gonna use this library from Python, but then it's probably not worth it to study. I'm gonna study directly the library, the BeautifulSoup one, and they're probably not very closely related. So let's try this. So I have to remember where it's gonna save this. So one more time, if it is requests or requests, yeah, requests with an S. fast. So yes, for script creation. Oh, name. Take this walk off here. Test here. Yeah, so it should work now. So hopefully it's much simpler to see. Oh, and I did it with the directed graph. Is this correct? Oh yeah. Oh, but it loaded, so I want to keep like that. Keep it like that. Nice, this is much cleaner. And it's small, so hopefully I'll be able to use it. So I'm gonna pause it here. This stuff, this stuff, here, here. I think this is fine. I'm gonna spend too much time. So probably I'm gonna keep this one open, but I'm gonna close this file here. And now I'm gonna put this to the left. Oh, this is a problem. I can't. And then if I redo them, but I wonder if that's too much work. So I'm probably not gonna use this one. I'll just use this show here. But then if I do this, it's gonna be a problem. Maybe if I do that. No. So I think I'm gonna navigate because otherwise I can set options there automatically make this bigger so this doesn't show up and then I get full screen there. But I think that's gonna take too much time. So I'm gonna just do this and explore through here first. And after I do that, I'm just gonna put this on the other screen, the other monitor. And I'm gonna navigate with that and search for the files in here. So I'm gonna watch the videos now, I guess. I'll be right back. So I think before I even watch this video, I'm gonna go through a quick walk over here. So I'm gonna remove this stuff from here. Maybe that was a bad idea. But on this, yeah, it seems like it's connected here on the loop. Let's see, it comes from here, goes through here. So maybe if I could remove this, the issue is that I don't want to remove dot by dot. It's the problem. So I think I moved them a long ways ago. So probably gonna put some music here. So yeah. So it starts on the request API .py using the get, then the request, init, sessions, then it use, then goes through request structures init, which has all this file is pointing to. So now that I don't understand really well, because there's nothing that this file is pointing towards. So I guess it's just because it's the init file probably. It's not clear. Oh, here. There's an arrow here. So this goes through here. With set item, request structures, it goes through here. Now this files. So this is request internal utils, burial, prepare method, what better mirrors. Get key value, merge setting. So it pretty much activates a bunch of stuff from the requests library. From here. Then let's see. Goes here. Goes here. This merge setting. Sessions. Gen expression. Initialize the cookie part of the thing. Then it goes on the journey here. Prepare body, prepare content. So I think this does most of the work for the BeautifulSoup library to parse stuff. Okay, but this goes sure. And also references back to itself. Yeah, so from this one, it goes through this path here. So this get item is the function on the file structures that goes to this other path here. Models. So models, sessions, models. Then it goes to this file. Then it initializes the content or models in request initializes BS4. Let me see here. Yeah, so I guess it's when I do this method here. No, this is just the get request. So it's probably when I do this result.text. Doesn't make much sense, but no, it actually makes sense. And this apparently references itself. So the first file is activated as deprecated argument. The second lookup, initialize the lookup. Then it's initializing HTML parser. Yes, builder init HTML parser. And then this one goes through a journey here. Which activates all the big ass things. Init. Initialize soup. And this one is what? So this is init and the elements. And this is init elements as well. This isn't init, this is setup anaconda. But this is on the same file. So these ones call each other. What's this big file here? So far, I think the element file is the one that's used the most. Formatter, daemon, element. Yeah, so I think that's the first one I'm gonna investigate probably. Handle data. It's not very good to read there. Shows that I'm lacking space here. Okay. You know, I think that's good. I'm gonna watch the videos and then I will look at the files. So I have to really know this library really well, and the Selenium library, I think, to do this project. It's probably the two ones that I need. So I need to become familiar with the functions that they're gonna use. Not that they're gonna use, that they have available. So I can think about what ways are gonna be the best ways to extract the information that I want to extract there on the site.
Document, so you can grab it from there if you want. This is just kind of a dummy HTML file, okay? So this is in the same directory as where I have this web scraping.py file. Make sure it's in the same directory, otherwise it's gonna be a bit of a headache. And what you're gonna do is open this file, then use BeautifulSoup to read it. So we're gonna say with open, and then this is gonna be index.html, comma, and then we're gonna say html.parser. So, sorry, not html.parser. This is gonna be R because we're opening this in read mode. I'm getting a little bit ahead of myself. And I'm just gonna call this F, standing for file. Okay, so with open index.html in read mode as F, and then what I'm going to do is say my document is equal to BeautifulSoup, and then I'm going to put F as the document that I want to read in here, and then I'm going to do html.parser. So there's a few other parsers you can use here. I'm not really going to talk about what those are, but pretty much since this is an HTML document, we want to parse it as an HTML document, so we write html.parser. This is like an accepted type for the BeautifulSoup module. Okay, then what I'm going to show you is just what this looks like as kind of a Python object. So I'm going to print out the doc and run my code and show you that we get the HTML document like that. So that's as easy as it is to actually read in an HTML file that is local on your machine. Now what I'm going to show you is one cool thing that you can do here. So it's usually better because your HTML is always going to be all kind of like jumbled together to prettify this before you print it out. So if you print doc.prettify, then what this does is give you all the indentation, and you can see this is a lot nicer, and it obviously is much easier to read. Okay, so that is how you read in a document. Now I'm going to show you a few pieces of the functionality. So usually what happens when you read an HTML file like this is you want to search for a specific aspect. If we're going to the example I mentioned at the beginning of the video, maybe you're looking for the price of something, maybe you're looking for the name, you're looking for maybe a table, usually searching for some type of information. So you need to be able to find that in the document. So the first thing I'm going to show you is how you can find things by the tag name. So actually I should go here and just print this out again. So obviously we have like the head tag, the HTML tag, the center tag, all of these things. It's really easy to actually find stuff that is named a specific tag in BeautifulSoup. What you can do is doc dot and then the tag name, and this will actually give you access to the first tag that has this name in the document. So just bear with me for a second here. I'm going to say tag is equal to doc dot, and then we'll go with title, and then what I can actually do here is print out the tag, and you'll see that this is the title tag, right? So if you want to access a specific tag, just put the name. Now obviously if there's multiple things named or using the same tag, it's only going to give you the first one. I'll show you how to get all of them in a second. Okay, so now that we have the tag, what if I just want to access what's inside of here? Well, to access the string that is being held inside of a tag, what you can do is use .string. So I can say tag.string, and then notice it gives me your title here. Now, one of the cool things about this, though, is I can also modify these tags. So what I can do is something like tag.string is equal to, and then hello. And now if I print out my tag, notice that it's actually modified this in place and changed it to hello. Now, what I can also do is show you that when I print the entire document again, so print doc, we don't need to prettify it. If we go here and we find the title, notice it's actually changed in the document. So the same way that you can access things, you can change them. Pretty straightforward. Now, there's a lot of other things you can change as well. I'll show you those in later videos, but that's kind of the basics. That's how you access what's inside of a tag, and then how you actually get the string within the tag. Okay, now what else can we do here? Well, we need to be able to find tags that aren't just the first ones that occur in the document. So in order to do that, what you can do is say doc.find, and then you can put the tag. So if I put the tag A, for example, here, this will give me any links, but again, this is only going to give me the first tag that occurs that has A inside of it. So what you can do instead is find all, excuse me here, if now I print tags, you'll see this will give me all of the A tags in the document. Actually, I'm going to go with P because I don't know if there's multiple A tags here. And when I do this, notice I get all of the P tags being printed out right here, and also shows me what's inside of these P tags. Okay, so that is how you can get them. So as you probably noticed here, these P tags have things inside of them, right? Like this P tag has another tag inside of it. So I'm going to show you now how you can actually access the nested tags. This is the exact same way that you would access the tags just from your regular document, but now you're going to do it on an existing tag. So this will show you kind of how
Let's see if I do HTML parser.
this works, but so this is pretty straightforward, but let's just have a look here. So let's say we want to access the very first tag, so tag 0. In fact, let's just put a 0 right here. And I want to access, let's say, actually, let me print this out and see what we get here. Maybe I want to access the B tag, right, or all of the bold tags. Well, if I want to do that, what I can do is the following. I can say tags.findAll, just like I found everything on my document, and then I can access the B tags. And when I do this now, it gives me all of the different B tags, right? And then same thing within here. I can go and access the text of these B tags, or I could go and access maybe the italics tag or whatever I want. But that's kind of how you can search through and parse the document. And again, I'll do an entire video on how you can actually find stuff in more detail. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and the series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have over HTML from a website. So what I'm going to do is go to my command prompt here in the same way that we install BeautifulSoup. We are going to now install request. So follow the same format of installing as I showed you previously, but pip install request. And you notice obviously I already have this installed, but you guys won't most likely. And now we can actually access a website. So the website that I want to access is actually Newegg. And as I mentioned, we're going to be looking for GPU prices later in the video series. But for now, let's say I just want to check the price of a specific GPU. So I'm going to steal this link right here. This is for a 3080, and this is the price. I'm going to show you how we can actually find and access this price. Okay, so what I'm going to do now is I need to leave this import, and I need to import request. Now, what I'm going to do is say that my URL is equal to the URL of whatever website I want to access. And then what I'm going to do is I'm going to send a request. I'm going to say my result is equal to request.get, and I'm just going to put my URL like this. So super simple. All this is doing is sending an HTTP GET request to this URL. It's going to return the content of the page, and the content of the page will be stored in result.text. So if I do this and I run my code, notice we're going to get a bunch of gibberish here, but we are actually getting an HTML document, okay? Now, to prove this to you, what I'm going to do is now read in result.text using BeautifulSoup. So I just need to jump in here for 1 second and quickly mention that the URL that we're using here does actually allow us to grab its HTML from a script. Now, there is a lot of websites, Amazon is one of them that I tried and that I failed with, that have like bot protection built in, and that don't actually let you grab the HTML of a page by just doing what I'm doing right here. This is a super simple way. We're just sending sending a GET request from a Python script, websites can detect you're using a script and they'll try to actively block you. Now, there's some kind of like policy and legal related stuff when it comes to scraping websites. So just make sure you're not like spamming requests on any websites or like DOSing or DDoSing anyone or something like that. What we're doing here is most likely fine, but I just want to mention that there's a lot of websites this won't work for. And if it don't work for it, I'm not necessarily going to show you how to get around the anti-robot stuff. Regardless, let's continue the video. So I'm going to say that my doc is equal to BeautifulSoup result.txt, and then in the same way as before, we want to use the HTML.parser, and then I'm going to print out the doc.printify. Okay, so let's run this. I'll go back to the code in a second in case I went too fast for you. And now notice, obviously it's quite long, but we are actually getting the HTML document. Perfect. So we can see all the div tags and everything like that. So now what I want to do is actually find the price of this GPU. So let me go back to the website right here and notice that this is what the price looks like. Now I'm going to assume that I don't know what the actual figure is. I don't know that it's $2,600, and I just want to look for the $ and then find the price afterwards. So to do that is actually pretty easy. What we can do here is go to, let's just make a new variable, and let's say prices is equal to, and then doc.find_all. But this time we're not looking for a specific tag. We're looking for some text. The text I'm looking for is a $. So I'm going to say text is equal to $ like that, and then I'm just going to print out prices and show you what we get. So run this, and notice we get $2. Now, that's not very helpful. Obviously, we want the entire thing, we want the actual price, not just the $. But the thing is, these $ actually allow us to access what the price is. And the way we can do that is by using this thing called a parent. So the way that this is kind of set up, BeautifulSoup, is everything is in a tree-like structure. So when you read in the document, the HTML tag is kind of the first, I don't even know what to call it, branch of the tree, if you want to call it that, or the root of the tree. And then there's all kinds of tags inside of the HTML tag, right? So if I have HTML here, I have a head tag inside of the HTML tag. Inside of the head tag, I have the title tag. And we kind of have this tree-like structure where a descendant of HTML is the head tag and the body tag. A descendant of the head tag is the title tag. And then these tags right here also have a parent. So the title tag's parent is the head tag. The head tag's parent is the HTML tag. Pretty straightforward, but it just works in kind of a general tree structure. And so what we've accessed here, let me just write some kind of pseudo HTML here, is imagine we have a p tag, okay, and another p tag, and then we have like our $, 2,613, whatever it is. We've accessed this single $ right here. And so if I access this $ and I want the entire price, what I want is the parent of this $, because this, just like everything else, is a descendant of whatever its parent is. And so if I access the parent, this will give me the contents of the entire tag that this $ is in, and then I can try to search for the 2,613. Hopefully that kind of makes sense, but that's the best way that I can really explain that to you. So anyways, we have these prices. What I'm going to do now is say prices 0 dot parent, and let's just print out what this is. So let's just say parent is equal to that, and let's print the parent and run this. And notice we get this kind of large tag here, right? And we have this list item tag, and then we have the price current label, and then we have strong, and then we have what the actual price is. So what I want here is what's inside of this strong tag. I want the actual value. So what I'm going to do now is search for the strong tag within the parent tag, and then I'm going to look for the contents of the strong tag. So now what I'm going to do is say strong is equal to parent.find, and then I'm looking for strong. And then I will print, not strong, like that. So now when I do this, notice that we get 2,613. Perfect. Now I just want to get the 2,613. So what do? I use my .string, and I get 2,613. All right, so with that, I am going to end the video here. I just want to give you a quick introduction to how this module works. In later videos, I will show you more advanced stuff and all the other features that you need to know. In my opinion, this is a pretty cool thing, really easy to use. Hope you guys enjoyed the video. If you did, make sure to leave a like, subscribe to the channel, and I'll see you in another one.
So he uses those objects. Let's see if I can do this. Yeah, but now I'm gonna take this off here. Because I just wanna test things out. So he uses this object to get stuff from. So the issue here is that I'm gonna have to learn Selenium first, I think. Maybe they go hand in hand. So I think that there's no way to, probably for a website, to know if you do it through the browser.
Hey there, how's it going everybody? In this video, we'll be learning how to scrape websites using the BeautifulSoup library. Now, if you don't know what it means to scrape websites, basically this means parsing the content from a website and pulling out exactly the information that you want. So for example, maybe you want to pull down some headlines from a news site, or grab some scores from a sports website, or monitor the prices of some items in an online store, or something like that. Now, to show an example of this, let's take a look at the finished product that we'll be building in this video, and then we will learn how to build it. So I'm here on my personal website, and on my homepage here, I have a lot of different posts of my most recent videos, and every post—
So let me check on other stuff here. Yeah, so when I go here JavaScript. So when I click array, it shows it like this. So one simple thing that I think about doing here is changing this URL with these formats here. And then the only thing I have to do is figure out. But I wonder if I have to do this manually or if there's a better way. And when I click on each one, it changes the page. But I don't think I'm gonna get the description. I'm just gonna get these ones, the name. But if I click here, is a different URL. So here's global objects, and here array buffer. Yeah, so when I click is global objects, then atomics. So it's a different path there that is using. Shouldn't be that hard actually. Now that I think about it.
As a title here, that is a big heading tag, and then I have a text summary of the video here. And then
so there's two things that I need to figure out. One is how to click. I'm gonna erase all of this stuff. So I'm gonna put here how to click using Selenium. How to get the names of the divs I want. Create for loop to do it recursively until all of them are done. But now I just thought about how I'm gonna figure out where is the end here. Because if I do this, which is another problem. Maybe on this I can inspect here. Try to use this. Yeah, maybe it contains here inside of this class. But I don't see it. Yeah, so in this list here, I can get all the lists. So I think what I need to do is put this on a list. Yeah, this might be easier even than using Selenium. I put this on a list, then I figure out how to loop through them. Yeah, first I need to parse the string with the link, figure out how to loop through them, and then I click, and then it's gonna get me to a different page. Yeah, but if I do it with the directly here, it's going to be different. So let me inspect this one. Yeah, so inside of this, each one of these, there's a list, maybe. Yeah, so inside of each one, there's a list, another list. So it might be easier than I thought, actually. All I have to do is figure out how to do it for the first one. Yeah, I need to get this element first, which is the list. And here, oh. And this is the class that changes here when I click that. So I need to get this one, div list, sublist, inside of this. Yeah, this one inside of this, then I get all the names. all the hrefs, put them into a list, and then I do the same action for all of them. Which is to find the sublist. Oh, but I will have to click because here is not showing up. So it only shows up when I click here. Because it changes the... Yeah, it changes the document. Yeah, but then I can create another one with a different URL. So first I get the list and I create another one with the different URL that's gonna loop through this because they're all gonna be the same. And they're just gonna change the name here. Then for each of them, I can create the same script as well. So probably not even gonna use Selenium. Which is gonna be better. Because then I just can focus on BeautifulSoup, so. To get all links for JavaScript in a list. Create different raw requests to access each of those links. Then build script, build function to put all of them in a list. To put all of them in a list first. Then I wanna put them on a dictionary. And so this has to be a list of dictionaries. No, from the list, I'm going to this and do this. Yes, I'm gonna create a dictionary with each one of these. It's gonna be arrayed in the list with the sub things. Then I'm gonna append this list to JavaScript. So JS list is gonna be list with array, then the list of the array. Max. And then so forth. I think I'm just gonna write this so I don't forget. And this is the plan. So what do I need to figure out? I need to figure out how to access links and divs. And yeah, links and divs. Yeah, that's about it. So I'm gonna keep watching these videos, then study the library, then start working.
Have a link to the video. So let's say that we wanted to write a scraper that would go out and scrape all of this information. So I wanted to grab all of the post titles and summaries and links to the videos from my homepage, and I wanted to ignore all this other information. So to do this, I have a finished version of what we'll be building in this video, and then we'll learn how to build it. So right now I can just run this with Python, and this is called cmsscrape.py. So if I run this, then this went out and scraped all of the titles and summaries and links. So we can see here we have a title, so this is my CSV module video, and then we have the summary text here, and then we have the link text here. Now, not only did this go out and scrape this information from the website and print it out here in the terminal, but it also created a CSV of all this information as well. So if I open up this cmsscrape.csv, this should open it up in Numbers, but you could also open it up in Excel. Now, this isn't very readable right now, but if I make these columns a little bit smaller here and then wrap this text, then we should be able to read this. So you can see we have a column that has all of our headlines for all the articles on the homepage, and then all the text summaries, and then a link to each video. So that is what web scraping is. It goes out and it pulls down all of the information that you want from a specific website. So now I am going to clear those out and pull these back up. Now, if you're trying to parse out that information with something that you had built in Python yourself, then you probably run into a lot of issues. But luckily, there's the BeautifulSoup library that makes parsing out all this information a lot easier to do. Now, we'll also be using the request library in this video to make our web requests. Now, you could use the built-in URL lib module, but the request library is extremely popular for fetching websites, so we're going to go ahead and use that. So let's go ahead and get started and see how to do this. So first of all, let's make sure that we have everything installed that we need. So to install BeautifulSoup, you can just use the pip install command. So to do this, we can just say pip install, and this is BeautifulSoup, and this is BeautifulSoup 4. So you can see that I already had that installed, but if you don't have that installed, then yours should just go through the installation at that point. Now, you definitely want to install BeautifulSoup 4 because there is an older version just called BeautifulSoup, but BeautifulSoup 4 will give you one that's most up to date. So once that's installed, then we need to make sure that we have a parser to parse our HTML. Now, I won't go deep into the details of these parsers, but there are some small differences between the parsers, and they could return different results depending on the HTML that you're trying to parse. Now, if you're trying to parse perfectly formed HTML, then those differences aren't going to matter. But if there are mistakes in the HTML, then the different parsers will try to fill in missing information differently. So BeautifulSoup has a section in their documentation about the differences between those parsers, and basically they suggest installing and using the LXML parser. So that's what we're going to use in this video. Now, they also say that the HTML5 lib parser uses techniques that are part of the HTML5 standard, so you could use that one too. But most of the time, the choice between the parsers isn't really going to matter all that much as long as you're working with good HTML. But I'll go ahead and leave a link to the differences between those parsers in the description section below if you want to read more about those. So to make sure that we have the LXML parser installed, we can install it with pip also. So we can just say pip install, and that is LXML. So if we run that, then I already have that installed, but yours will install there if you don't already have that. Now, if you want the HTML5 lib parser, then you can just do a pip install HTML5 lib. So like I said, we'll be using LXML in this video, but the HTML5 lib is popular as well. So now we also need the request library, and just the same, we can do a pip install request and run that. You can see that mine's already installed, but if you don't have it, then yours should get pulled down right there. Okay, so now that we have...
another beautiful idea I have is put them on a list instead. These languages. And then I could loop through this list. JavaScript, Python. Etc. And I can pass this list to here. Loop to the list. And then whenever I wanna do this for different languages, I can just do this. And that's perfect. Yeah, nice.
Those installed. Let me clear that out. And now let's take a look at what we can use these for. Now, you don't have to be extremely familiar with HTML in order to scrape websites, but it definitely helps to know. So basically, HTML is structured in a way where all the information is contained within...
Do they have C++ here? C++, nice. So there's only one file for C++. There's a lot of links. So that might be an issue as well. But I think getting from here is going to be a lot easier than searching the internet. So I can also create a script to scrape this and stuff. But I think it's going to be much more difficult because then I'm going to have to figure out, maybe they're all in a div, so I can do that. So I need to know how to access divs. I'm going to put this. Oh, access divs and links. Yeah, this is what I need to know.
Tags. And if you're at all familiar with XML, then it's very similar to that. Now I have a very extremely basic HTML file open here in my browser. So we can see that this small example just has one big header here that says test website. And then we have two large links here for articles. And one is the article 1 headline, and then it has a small text summary here below that. And then we have a big article 2 headline here with a text summary below that. And then we have a footer down here at the bottom. Now this is how browsers display HTML. We are using the Chrome browser right now. But in the background, the source code looks a bit different. So I have the source code for this very basic website pulled up over here on the right side of my screen. So let me make this a little smaller here, and then I will stretch this over so that we can better see the source code. So we can see how this is structured. So we have these tags throughout our document, and they are opening tags that are surrounded by these angle brackets here. So we have this head tag that opens the tag, and they also have closing brackets down here, which are the same, except they have a / after the first angle bracket. So the close of our head tag will be this line here, and everything, all this content is within this head tag. So all this here is a single head tag, and all of these tags can be nested. So if we want to find our article headline and article summaries, then we can look down here in our body tag. So we have an opening body tag here, and within the body we have our test website H1 here, which is a heading, and then we have a div tag here, which has a class of article, and within this div we have our H2 tag, and H2 is another heading, a subheading, and within that H2 we have a link. These A tags, which are anchor tags, these are links. So this is the text to the link here, article 1 headline. That's what gets displayed over here in the actual website. We can see article 1 headline, and this href, this is actually where this links to. So this links to a page, article1.html. Now these classes here, how this has a class of article, these are mainly used for CSS styling and can also be used within JavaScript to identify specific elements. Now below that heading tag that we looked at, then we just have a paragraph tag here, which is just a P, and this is the text summary of that article. So we can see here that this entire div with the class of article has our H2 heading and then our paragraph for the summary. And then this is just repeated down here. So for our second article, we have another div with the class article, and then another H2, but this one is for the article 2 headline and the article 2 link, and then the summary text for article 2. And then lastly, we have a footer down here at the bottom that is just a div with the class of footer, and that has a paragraph tag within there with some text. So everything else in here is just extra information. So we have some scripts, and up here at the top we have some style sheets and things like that, but all of this in the body is what gets displayed over here in the website. So let's use this very simple example to see how we can parse out information using BeautifulSoup. So I'm going to open up a file here called scrape.py. Now all we have in here so far are our imports for BeautifulSoup and requests. So we have from BS4 import BeautifulSoup, and then we're also importing requests. So let's say that we wanted to parse out the article headlines and the summaries from our very simple website over here. So in this example, it's just article 1 and its summary text, and then article 2 headline and its summary text. So first things first, let's pass our HTML into BeautifulSoup so that we can get a BeautifulSoup object. Now there are a couple ways to do this. We can either pass in the HTML as a string, which is what we'll do in a minute when we parse our website from the internet, but we can also pass in an HTML file. And in our case, we have this sample HTML file within our current directory. So let's go ahead and just open up this file and pass it in to BeautifulSoup. So to open up this file, we can just say with open, and this HTML file is called simple.html, and it's within the same directory of our script, so we don't have to specify a path. And then we're just going to read that in, so read is the default, so we don't have to do anything there. And I'll just say as HTML file, and then to pass that HTML file into BeautifulSoup, we can just say soup equals BeautifulSoup, and then we'll pass in that HTML file. And now we need to specify our parser. And like I said, for this video, we're going to use the LXML parser. Now, if working with files is new to you and you want to know more about this, like with open statement and things like that, then I do have a video specifically on working with file objects, and I'll leave a link to that in the description section below. Okay, so now we have this soup variable, which is a BeautifulSoup object of our parsed HTML. So let's just print this out and see what we get. So we can just print out soup. So if I save that and run it, then let me make this a little bit bigger here, so we can see that this just prints out all of the HTML, and so it's very similar to what we just looked at. Now this HTML isn't formatted in a very readable way. It's all pushed over to the left. If we actually look at that simple.html file, we can see that it's nice and indented. So in order to format this to where we can more clearly see which tags are nested within each other, then we can just use the prettify method to clean this up a bit. So if we say soup.prettify, and that is a method, so we have to put in parentheses there. If we save that and run it, now we can see that it indents these to where we can see what tags are nested within each other. So here is that head tag that we saw before, and then everything that is indented within that head tag is belongs to that head tag. Okay, so now let's see how to grab information from this HTML. So the easiest way to get information from a tag is to just access it like an attribute. So if we wanted to grab the title of our HTML page, and if I look here at our HTML, this should just be test a sample website is our title for this. So the easiest way to get that is to just access it like an attribute. So I will say match equals, and we will do soup.title, and then we will just print out that match. So I'll save that and run it. Then we can see that it parsed out that title tag. Now it still has the title tags around the text. So if we only wanted to grab the text of the title tag, then we can access the text attribute of that tag. So we can just add that to the end here. So we'll say .title.text. So if I save that and run it, then you can see that now we only get the text of that title tag. Now searching for a tag like we did here by accessing it like an attribute by saying .title, that will get the first title tag on the page. But the first tag on the page might not always be what we want. So we can use the find method to do something similar, but it will also allow us to pass in some arguments that we can find the exact tag that we're looking for. So for example, if I use this .access to find the first div on the page, and I do soup.div, if I save that and run it, then we can see that I got the first div tag on our page with all of its child tags, which is everything for that first article. But if we wanted to grab the div tag that has a class of footer, for example, then we'll have to use that find method and pass in some arguments. So let's use that find method. So we'll do soup.find, and now we will search for a div. Now if I save that and run that right there, then we just get the same thing. We just get the first div on the page. But with this find method, we can pass in arguments of attributes that narrow down exactly what tag we want to find. So for example, I can pass in an argument of class, and then after class we need an underscore. Class underscore equals footer. Now these arguments can match any attributes that your tag might have, and most of the time you can just pass in arguments just like they are in HTML. So if you want to match a div with an ID of footer, then you can just pass in an argument of ID equals footer. But the reason that we need an underscore after class is because class is a special keyword in Python Python. So they use class underscore instead. So if you were confused about that, then that's why they have that. So if we save that and run it, then we can see that now we're not getting the first div on the page. We're actually getting the div with the class of footer. Okay, so now let's say that we wanted to parse the HTML and get all the article headlines and summaries from our page. Now, anytime that we want to get multiple things from a page, a good way to start is to just get one of whatever it is that you're trying to parse. So for example, if I wanted to grab the headline and snippet from each article on our page over here, then let me start by first grabbing that information for one article. And once we have that working, then we can apply the same logic to all of our articles. So if we go back here to our browser and look at our page, now in order to dig down into the HTML and find exactly where our article headline and summary is, within the Chrome browser, we can just right click on whatever it is that we want to parse and then click on inspect. Now, I know this is a little small. Let me make this just a little bit bigger here, and then we'll walk through a little bit of how to use this. So I'm using Chrome here, but pretty much every major browser anymore has something like this, and this is really useful for finding exactly what you want. So within the inspect here, if I just hover over our div class of article, then you can see that in the top part here, it's actually highlighting that entire everything that is within that div. And if I go down to the H2, then it only highlights that H2. And then if I hover over the href, then it highlights that link. And if I hover over the paragraph, it highlights that paragraph. So we can see exactly what is what. And the same with the second article. If I go down here and hover over this article, I can see that that has the article 2 headline and summary text, and I can click on this little arrow here to expand this, and then it shows me everything that is within that div there. So we have the H2, the anchor tag, and then the paragraph tag with the summary text. So just like we saw before in the source code, our article headlines are within a div with a class of article, and then an H2, and then an anchor tag. So let's go ahead and grab the article div. So let me make this a little smaller here so that we can see this. So let's grab that first div with the class of article. So I'm going to change this variable name here over to article and then print that out. Now this is going to be a div with the class of article. So if we save that and run it, then we can see that now we have that first article, and we can search that matched tag just like we search the entire HTML document. So we can access child tags with a dot access like an attribute, or we can use the find method. So for example, if we wanted to dig down into the text of the headline, then we could say headline is equal to, and now we don't want to use that entire soup, which is the entire HTML. We only want to search within this article. So now we'll say article.h2, and within that h2 we want to access the anchor tag, so that is .a, and now we want the text of that anchor tag. So we can just string all of that together. So with all that strung together, if I print out that headline and save that, let me comment out this entire article for now. So if I save that and run it, then we can see that it grabbed the text of that first article's headline, and we can do the same thing with the article summary. So it's just a paragraph within our article. So if we go down a couple lines here, then we can say summary is equal to, and that is article.p, so just to grab that paragraph.text. So if we print out that summary, save that and run it, then we can see that now we have that article 1 headline text, and then we have the text summary of that article as well. Okay, so now we have the code here for grabbing a headline and a summary from a single article. So now we have this information for one article. We can most
So let
likely
me write this find there. So all I need to do is put div and then whatever I want to find, which is going to be the class. Huh? Oh, that should be. Oh yeah, because that's a method from Python, so you can do that.
use this, reuse this information to parse the information from all of our articles. So right now, we're using this find method to just get the first article, but now we need to loop through all of the articles. So to get all of the articles, instead of using find, we can just use the find all method. Now, with find all, instead of just returning the first tag that matches these arguments, it will instead return a list of all the tags that match those arguments. So instead of just...
So now that finds underscore all, and here I'm gonna put so let me go back to JavaScript. Yeah, inspect here. So href. Oh yeah, so I wanna get a div class list. So I'm gonna do that. And this, whenever you do this, it means that it's probably meant to be a private or variable or function or object. But I think I'm gonna do this for now. Maybe I'll change it. But the issue here is that there's a div inside of a div, so I'm not sure which is inside of this section. So there's section, then there's this row navigation, and then there is the div. So I'm not sure if it's gonna find it. And all of them have the same class. Maybe it is because that's the class. Or in this class, list item. I can just create list directory. Oh, so is this whole name there? So I can copy like this. Here, put it here. So I think I'm just gonna put lang item, lang list. That way is better. Maybe I should run this and see what I get in return. Empty. So that's gonna be a problem. Because I need to figure out how to get it inside of the thing. And I think this changes also. This might be why. It's not showing anything there. So if I close, yeah, now it's not active anymore. So now it's open, now it's not open. So that is a problem because how I'm gonna know what is the main thing about this. Maybe I can search for title instead. Yeah, title is much better and easier. Let me see if I erase this, if I'm gonna get anything. Nothing. I'm gonna erase until I get something. Still nothing. So let's try title here. Might be a lot easier. But I also wanna know how to search for divs inside of divs and what should do if they have built-in functions like that, where the class might change. And here might be title. So I think it's correct. I'm just gonna copy it just to make sure. Copy exactly the same. It's still an empty list. Oh, it's because I'm searching. No, I'm searching on the right one. Let's see. Maybe not. Doesn't change the URL, so yeah, should be the correct one. So that's strange. So let me keep watching the video.
Setting this variable, we can now loop over the list that returns. So instead of saying article equals, we can just create a for loop. So we can say for article in soup.findAll, since this returns a list. So now we have a for loop there. I'm just going to get rid of that print article line. And then I'm going to put this logic here for grabbing the headline and summary from an article within that for loop. And now it'll loop through all the articles, which in this case is just the two of them. And we'll get the information for both of those. And also let me put in one more blank print statement here within our loop so that at the end we have a blank line between our articles. So if I save that and run it, then now we can see that we have the article 1 headline and the summary for that article. We also have the article 2 headline and the summary for that article. Okay, so this is good. So we're starting to see how this would be useful for getting information from websites. So now let's do something similar, but with an actual website. So like we saw before, I have my personal website pulled up here in the browser. And like we saw, if I scroll down, then we can see that we have a lot of video headlines and summaries and the embedded videos themselves. So let's say that we wanted to grab these titles and these summaries and links to the videos. So first things first, let me just delete what we had so far with our simple HTML file that we used. And I'm also going to get rid of where we are passing in that file. So first things first, we want to get the source code from my website using the request library. And to do this, we can just say source equals request.get. And now we want to get my website, which is just http://coreyms.com.
Oh, I'm
now,
also gonna do that instead because I think it's better. I'm gonna import requests directly. Requests. Because otherwise this get here is just along there, it doesn't look right. Then I'm gonna erase this stuff here. So this light is too strong.
Request.get will return a response object, and to get the source code from that response object, we can just add on .text to the end. So now the source variable should be equal to the HTML of my website. So now we can pass this into BeautifulSoup. So now let's see if that worked. So if we print out soup.prettify like we saw before, then this should print out the formatted code for my website. So it looked like that worked. If I scroll up here, we can see that this does look like HTML. It's kind of a mess because it's a larger website, but we can see that these links seem to be coming from my website. So it looked like that worked. So now we can start parsing out the information that we want. Now, just like before, let's start off by grabbing one video's information, and then we'll loop through to get the information for all the videos. So to grab the first headline and snippet for the first post on my page, let's inspect my website and see if we can figure out what the structure is. So I'm going to make this a little larger here. And now I'm going to use that inspect functionality again within our browser to see if we can pinpoint exactly where this information is that we want to parse. So if I hover over my headline and right click on that and go to inspect, then we can see that it is a link inside of an H2 here.
I think what I'm going to do is watch these videos off stream. I'm going to search for this now. Let me move this through here. Guys, I can close this for now. So I'm going to navigate to the execution of the file to see, but I'm only going to open once it gets to the BeautifulSoup library. So here. So then after I do this and I read all the documentation here, I'm going to watch a bunch of videos off stream about it, and I'm going to try to figure out how to access the documents there. Then once I figure that out and I have a script, I might stream again. Yeah, but it shouldn't be that hard actually. It should be very doable. And then if it works, I'm going to do it for more languages. And I'm going to use that network graph to study JavaScript and Node.js and all the other stuff. And then I'm going to use those libraries to build the other the other websites that I want to build. Another thing that I just thought about is that I can also use these scripts that I created to visualize dependencies, to create simple websites and visualize what's happening. That also should be good to learn. So when I'm solving the free code camp challenges, I'll probably do that at some point. When I'm sending information to MongoDB. So here it goes from request model. Let me see. RS requests. So now I want to see, yeah, other idea. So where is this? Oh, models here. So from this file and request and is accessing content. So maybe I should do Control F, content. I'm not sure if it's a function or something else. Oh, here. Nice. Let me close this stuff. Content of the response in bytes. Oh, so it makes sense. So from this it goes to BS4 init. And let me see. So it passes south. It has this add property here, which is a wrapper. It's a built-in wrapper from Python, I think, that allows you to put a property on this method here, this function. But I'm not sure really well how it works. I have to look at it again. If self.content is false, read the contents. If self.content consumed, raise runtime error, the content for this response is already consumed. Status code is equal 0 or self.0 is false. So I guess when it doesn't have status code, or self.raw is none, self.content equals none. Else self.content equals b dot join self.either content check size or b. Self.content consumed equals true, return self.content. But now is difficult because I need to understand which part of this is calling the BeautifulSoup initialization. I think it's the self, probably because there's nothing clear here. Maybe it's this property method. So what is the class here? And that's the hardest part that I found when I was studying the other library as well. Is this things that are not explicit in the code, but they work in the execution because it's just passed by references. So this object, for example, it receives from somewhere else, from a different library. Then it becomes hard to track where it comes from. And what part of the code is accessing the other file. So this class has these attributes. Integer code of responded HTTP. So where is this coming from? Oh, here. Receives as an argument. And to do that, you just press Ctrl B there while highlighting the stuff. So self, obviously, I'm not gonna get anywhere pressing Ctrl B because it's just gonna reference to the argument. But this content, however, goes through here. So it is in the models, optional bytes, class response. So I guess this is the class that gets activated by the request here. So whenever you do the request, this becomes the response, I guess. Oh, and then I'm activating the text here. Dot text of the response. I think. But it's not showing here. on the graph. It shows iter content, iter slices. Oh, I guess it didn't see that. It goes on a loop before it calls the file. So it's going through iter contents, iter slices, generate, exit, close, close, then text. Then after it goes through text. So I guess I'm gonna follow the execution of this. So Control F, iter underscore contents. Okay, so content here. Self chunk size optional int decode bool iterator any. So I need to study what's there in Python. So it takes these arguments. I guess it's gonna take self when it calls it. Oh, but the first thing that it calls is content. Then it goes straight to content. So it goes from there to here. And this, I guess, decodes the response to the iteration of the content. So this is probably an iterator. Then it goes from these two iter slices. Oh, this is in the end here. It's not that big of a file. Oh, so I'm on the wrong file as well. So go back to here. Yeah, let's look this up. Oh, so it makes sense here. So it calls here on self join. On join.self iter contents. Also, I can just press Ctrl B here. And then I go through this stuff. So iter contents. So I guess this is gonna, oh, so that's probably in C, that other file. So this is not from Python. It's from C Python, maybe. Because it's a different extension. Maybe C Python, yeah. Interesting. But I'm still gonna research this. Iterates over the response data when stream equals true is set on the request. This avoids reading the content at once into memory for large responses. The chunk size is the number of bytes it should read into memory. This is not necessarily the length of each item returned, as decoding can take place. Chunk size must be of type int or none. The value of none will function differently depending on the value of string. If the code Unicode is true, content will be decoded using the best available encoding based on the response. So this calls iter slices at some point. So this has functions inside of it. If has attribute self.raw string, special case for URL libtree. Try for chunk in self.raw string chunk size decode. So I need to remember that chunk size comes from the arguments. And is one, so I think this is useful when you wanna parse larger chunks. Wanna pass it as an argument. Center file like object, self consume. Where stream consumed, and if chunk size is not none and not instance, is instance. So if it's not an int, raise type error chunk size must be an int. Yeah. Reuse chunks iter slices. So here it comes. So iter slices, self.content, chunk size, stream chunks generate. So this calls this recursively. is another interesting thing. I guess to read all the lines, maybe. I don't know. Chunks equals reuse chunks if self.content consumed. Oh, so it makes a clause to check if it's consumed or not. If it's consumed, it means that it already got the information. So it's not gonna read it. If not chunk break, yeah, yield chunk. Standard file-like object. Chunks equals reuse it, yeah. So else string chunks. Decode Unicode chunks equals string decode response Unicode. I guess this is another function from the class. Then it returns the chunks. So let's see where this goes. Iterate over slices of a string. This is interesting. If slice length is none or slice length less than 0, slice length equals length of a string. So if the string is empty, then this slice becomes length, which is 0. Oppose less than length string, yield string, pose, not pose, plus slice length. So this is putting them all together, I guess. So it first gets the chunks of data, then it puts them all together here using this generator. Pose until it reaches the length of the string. But I'm not really sure if I understand correctly. So is there any way that I can go back? Because Control B, I can search, I can access it, but to go back, I'm not sure. Whatever, I'm gonna keep going through the execution, so I don't spend too much time. I just wanna get an overall picture right now of how it works. And I'm still on the request, so I'm gonna move slightly fast. So from iter slices goes to generate. Oh, so I need to go back now. I think I'm gonna use Control F. Because I think what's happening is it runs this function until it ends and then it continues the execution of the other one, which is iter content. Oh, this is on another file. Am I crazy? Oh no, it's because it opened from the model. So I might be wrong about that. No iter slices here. No, it's correct. Yeah. So it goes to the utils file and then it comes back here. Once it's done with that, with parsing the strings. And then I guess activates this probably. Yeah. Which is in the same file. And it's inside the function. Yeah. Goes back recursively. Then exit because it's probably finished. But I'm not sure. So I'm gonna search this. Exit. Python. I think this activates every time a function. It can't be every time because it didn't activate the other ones. So yeah, I'm not really sure. Oh, it is not the same file. So it goes from this one to the sessions file. So let me see this again, actually. On the, I think I'm kind of lost here. Interlines. Okay, either content, then generate, which was the one I was at. Oh, then it goes through the utils. Oh, so it's correct, I think. Because this is the same as this. It goes through this file, then it goes back to the generate, and then it goes to the sessions, exit. The under method exit. So I think I can use exit here. Fine. Oh, so it's defining here. Self.close. But I'm not sure how you choose this link between files. I guess it has to do with the class, maybe. Because the only possible way is to do that without explicitly telling it here. Anywhere in the code is by if it uses the self, which is the only thing that is not explicit. So I'm gonna assume that is a property of the class that activates the other file there, which I'm not gonna read because I don't have time. So maybe there's something about session here. Oh, here, exit. So I guess this activates the session file. No, so activates this. Yeah, probably that's what's happening here. So get attribute self.raw. No, then it goes to this file here. Or whatever. So now from the session files, it goes to close. Which might be this. Yeah. Then from this file, goes to adapters. So let's see if I can, yeah, self.adapters. Those are adapters and as such the session. Yeah, activates this file, but this is not Python because it has the I here in the end. So maybe it's not this one. But it might be. Let me see this. Yeah, so it's probably that one. But it says Python there, so it's kind of weird. Let me see adapters. So it's saying that it goes through this file and then the close method on this file. So here, probably. That's probably, well, cleans up adapter specific items. Okay. Yeah, so that's what's happening there. The other file is the sessions file is activating the close on the py I file, and it deactivates this here, probably. I'll do Control F, close. So there's this, or maybe it's this one. No, I'm not sure. Supposes of any internal state. Currently, this closes the pool manager and the inactive proxy. So let me see the next file is models and then text. There's nothing about this here. And the only other one is this one. No. Yeah, the only other one is this. So maybe it's not this one, it's the other one. So clear. So proxy manager. Okay, so I think I'm gonna close this, go back to the models. Just so can go fast. Here is saying now that it goes through the text, which is this. Probably this one. Let's just make sure. Yeah. So it has to be this one. Content of the response in Unicode. The text. Then it goes back to the content. If response to Unicode is none, encoding will be guessed. Ensure that encoding of the response is turned based on solely on HTTP headers following this try char set from content type. Content equals none, encoding self.encoding. If not self.encoding, return string. So it returns, if not self.content, returns an empty string. If there's no content, it returns empty string. Go back to detect encoding. So content equals string self.content encoding yours replace, then returns this. So assume this is probably what's gonna initiate the VSFAR script. Yeah, and it passes an HTML as argument. So let me see here. Yeah, so this is the result and takes HTML. HTML.parser. Oh, so BeautifulSoup is taking result.text and HTML, so it doesn't pass any arguments. Just, yeah, it's the BeautifulSoup that takes the arguments. So let's go back there. So now tries this string self.content encoding errors replace. Lookup type error. A lookup error is raised if the encoding was not found, which could indicate a misspelling or similar mistake. Type error can be raised if encoding is none. So we try blindly encoding. String.self.content errors replace. So let's see if this returns anything. Goes back to here. Yeah, it's just gonna give me the reference, not more. So this goes back to the content of this file. So it's here probably. And then this initializes. Yeah, but I still don't understand how it's being initialized. So I guess it's not this that initializes the... Ah, that makes sense as well. So this is the portion... Yeah, this makes sense. So all of this happens on this line here. Whenever you run this line. And then it initializes BeautifulSoup. And then BeautifulSoup is probably gonna access the thing. So now I'm gonna go through PS4, neat. I think I'm gonna close this. So this is the first file that initiates and initiates the init method here. Probably of this class. Yeah, because it is the class that I'm calling here. Def init. I think I'm gonna close the window there. So far I'm really happy that I did the script. It does really help a lot to have a direction to go through when studying these things. Because now it's much easier to understand the flow of the things, of the execution. Whereas before I would be completely lost on what is going on. And here I can see the path that this script is going through, which is much better to understand what is calling what and what's happening. So after this, it calls deprecated argument on this init here. So I guess I'm passing the deprecated argument here. So this probably changed. Markup a string or a file-like object representing a markup to be parsed. I think I'm gonna decrease the strength of this slide because it's too strong. A string or a file-like object representing markup should be parsed. Features. So which one of these I'm passing? Probably this parse only. Desirable features of the parser should be used. This may be the name of a specified parser. Oh, so is this one. So I'm passing the features. Or it may be the type of markup to be used. HTML, HTML5, XML. It's recommended that you name a specific parser so that BeautifulSoup gives you the same results across platforms and virtual environments. So maybe if I use HTML5 here instead of HTML.parser. A tree builder subclass to instantiate our instance shoes instead of looking one up based on features. You only need to choose this if you've implemented a custom tree builder. Parse only a soup strainer. Only parts of the document watching the soup strainer will be considered. This is useful when parsing parts of a document that would otherwise be too large to fit into memory. From encoding a string indicating the encoding of the document should be parsed. Pass this in if BeautifulSoup is guessing wrongly about the document's encoding. Exclude encoding is a list of strings indicating encoding is known to be wrong. As is in, if you don't know the documents encoding but you know BeautifulSoup's guess is wrong. Element classes, a dictionary mapping BeautifulSoup. Classes like tag and navigable string to other classes you'd like to be instantiated and installed as a parse tree is built. This is useful for subclassing tag or navigable string to modify default behavior. Okay, so if convert entitled entities in keywords does not respect the converted entities arguments to the BeautifulSoup constructor, entities are always converted to Unicode characters. So I don't think I'm gonna let you read all of this. If is HTML in keywords, warn is not warn, BS4 does not respect the is HTML argument to the BeautifulSoup constructor. So it's calling this one. All of this in it. Old name, new name. If old name in keywords, warning is warn. So I didn't receive this warning, which is weird. The argument to the BeautifulSoup constructor has been renamed to this. Maybe I did receive this. Let me run this again. Yeah, it doesn't show up anything. Which is interesting that it activates this, but it doesn't show up. But I guess it's only activating because it's part of the init. So it activates anyway. Yeah, that's probably the reason. So the argument that I'm using is not deprecated. It just activates because everything in this script activates. In this init portion. If builder is none, builder. So I think I'm gonna go a little bit faster because I've been here for a long time already. So I don't want to get to the other parts of the library. So from this goes to lookup, still on init, which I guess is gonna be activated here somewhere. Not success. Yeah, I don't see it. If I just type lookup, usually it's gonna be the first. So there's only one here. So it should be this. A lookup here. Builder class. Inside of the init. Okay. I'm glad that the script is working as well as I intended to work. Then activates HTML parser from builder. Just for builder HTML parser. So this lookup is what activates the file. If the feature is not left 0. So if builder is not builder class, builder register lookup, builder init. Okay. Nice. Yeah, so but it's saying HTML. It's saying is that it doesn't go to this file, it goes to another file. HTML parser. Yeah, I'm not gonna look up. So it's saying that it goes to this file directly and doesn't go through here, but that function goes through here. So I'm not really sure. So I guess that doesn't go into the stack frame. And that's why it's not showing on the graph. Not really sure. So here it goes through the init again. Yeah, BeautifulSoup HTML parser. And then passes this argument here. And then from init it activates a bunch of stuff, which is the main thing, I guess. So there's 2 paths that it goes through. I'm gonna go through the one in the left before. Or maybe not. Yeah, so it's activating a bunch of things on the... Let me see which one goes through this first. So this one. This. Oh, so it actually stops there. Huh. So I guess it activates through here, but here is also saying that it stops. Yeah, so now it gets really confusing. Because there is no clear direction here. Oh, there's this one, but then it stops there. Oh no, it goes through here. So it goes on top. Goes here. And then on this one, it goes through a journey here. This, from this one. Yeah, this is far too complex. But goes on the init here, showing down init builder. So maybe, yeah, now it's showing this builder init. So maybe the order is off on the graph. Because this HTML parser is connected to a lot more things. And then from the builder, initialize soup. It activates initialize soup. Let's see how much time I spent here. Yeah, 4.5 hours. I think it's already a lot. It's like it's not. So I think I'm gonna stop here, and I'm probably gonna study this, continue to study this off stream, following this graph here that I'm using. So I was in this part here, and then here's the HTML parser, and then it starts getting complex. So I think I'm gonna investigate these 2 files here. And watch those videos. And then tomorrow I'll probably gonna continue this and build. Hopefully, after studying this library a lot, I'm gonna understand how to access this element here. And then continue on with this project here. So I'll probably come back tomorrow. And yeah, see you.